Okay, chapter 6, section 6, day 2. Here we go. We're going to solve some equations with logarithms. First of all, let's remember some of the stuff that we've been doing. Um, let's see here. We want to go log base 216 of 6 is equal to 1/3. A log is equal to an exponent. It's the base raised to the exponent. This is what we're taking a log of. 216 to the 1/3 is 6. Single log, remember, a couple of things you can do. We can go, this 3 can come up there, and then we can multiply. Addition is multiply, and subtraction is division. So I'm going to put all of this into a single log base 5, but I'm going to have, 6x cubed divided by 48. So that's a 6. This is the 6. This is the x cubed. That's the 48. Addition means multiplication. Subtraction means division. And finally, I could simplify x cubed, well, it's not equal to, x cubed over 8. There you go. First mistake of the year. Which of these is false? Just look at them each individually. It's a good little reminder of what we're doing here. This 5 can swing up there. These are the same things. You could also look at it as this 5 could swing out there. Subtraction turns into division, so this would be log base a of 6 over 3. 6 over 3 is equal to 2, so this one's okay. This one's okay. All the way down to the bottom, multiplication can be split up into addition, log base b of 2, log base b of x. You could also look at it going back the other way. And this one they changed the base, but this isn't the proper change of base formula. So I don't think that one's going to work because they just selected, this would be log base a of 1 over log base a of 3. It doesn't work, so that one's no good. Solve a logarithmic equation. Okay, here we go. We're just going to, I would rewrite this in exponential form. The base, a log is equal to an exponent is equal to x. Incidentally, you could type 8 to the 4/3 into your calculator, but this one is possible to do as the cube root of 8 all to the 4th if I was doing it by hand. You do not need to do it by hand, which then comes 2 to the 4th is x, and x is 16. Most of you that grabbed your calculator could see that 8 to the 4/3 is 16. So the answer, log base 8 of 16, is equal to 4/3 because 8 to the 4/3 is 16. Moving right along, same thing over here. I would rewrite this in exponential form. I would have n is equal to 27 to the 2/3. The cube root of 27 is 3. 3 squared is 9. If I type 27 to the 2/3 into my calculator, I get 9, no matter which way you swing it. Property of equality. Okay, this is going to be very similar to what we did back in 6.2. 6.2, we got the bases to be the same, and then we could drop the bases, and we could, so we had problems that looked like this. Like if I said, let's see here, if we had one back in 6.2 that was like, 5 to the 3x is equal to 125 to the x. Can you solve? And you did 5 to the 3x equals 5 cubed. Oops, there's an x up there. All to the x, and then you got 5 to the 3x equals 5 to the 3x. And now you could drop the bases and say 3x equals 3x, and x is 1. X is anything, actually. That was a bad example. But the whole idea here is getting it to be We want to create things that have the same thing. We're going to do that with logs now too. Log base b of x equals log base b of y. Then we're allowed to say x equals y. So if we can get a single log on the left and a single log on the right with the same thing, then you can let them equal one another. So here I have it. I'm already set up. Sometimes it'll be set up, sometimes it won't. This is a single log base 4. This is a single log base 4. And now I'm allowed to drop those logs. And I can say, well, then x squared equals negative 6x minus 8. And I can add that over and add that over. Well, how do we solve a quadratic? Factoring. When am I ever going to use this in my life? Right now, people. Right now. And I get 4 and 2. And I set them both equal to 0. And I set them both equal to 0. And I get negative 4. And I get negative 2. Okay, we do need to check our work on all of these. Plug back in there. Negative 4 squared is 16. Over here, negative 4 is times negative 6, positive 24 minus 8 is 16. I'm good. Plug this one in. Negative 2 squared is 4. Negative 6 times negative 2 is 12 minus 8 is 4. I'm good. So you do need to watch out because you're not allowed to take the log of a negative. So you do need to plug these back in and see if you have extraneous solutions. Same thing here, very similar. I can type in, or I can drop the logs. Single log. You can only drop the logs when you have a single log on the left and a single log on the right. Okay, so now I move these over, and now I can factor. And now I get minus 5 and plus 4, and x is positive 5, x is negative 4. And you check these out. 5 squared is 25, 5 plus 20 is 25. Negative 4 squared is positive 16, negative 4 plus 20 is positive 16. We have two solutions. Everything's fine. Okay, now it's a little bit different because now we're going to need to deal with the fact that we have 2 logs 2's on the left and 1 log 2 on the right. So the first thing we're going to do is we're going to get this to be a single log base 2. I'm going to move that up, and I'm going to get log base 2 of x to the 4th minus log base 2 of 5 equals log base 2 of 125. Now I'm going to make a single log on the left. Subtraction means division. So all of these rules are going to be used now. But once I get a single log on the left and a single log on the right, I can drop the logs, and I get x to the 4th over 5 equals 125. Multiply both sides by 5. X to the 4th equals 625. And now I'm going to take the 4th root, or raise both sides to the 1/4. You type 625 to the 1/4 into your calculator, and you get 5. Technically, it would be plus or minus 5, but I would not be allowed to put a negative 5 up there because then I'd be taking the log of a negative, and we're not allowed to do that. We don't have that. Bases are always positive. You can't take the log of a negative, so it's just positive 5. Same thing here. I got a little bit more going on. I got to be a little bit careful. So I'm going to take, and I'm going to move this guy. Let's see, we're going to go. We're going to put this up here, yeah. And I guess there's a few different ways you could do this, but whoops. Let's see here. Let's go with log base 3 of x minus 2 squared. And then I'm going to make this x minus 2, and this is a subtraction, so I'm going to put it over 6 equals log base 3, 150. Okay, so again, single log, drop the logs. X minus 2 squared over 6 equals 150. Times 6 times 6. X minus 2 equals 900. Oh, it's squared. Okay, square root, plus or minus, x minus 2 equals plus or minus 30, add 2, add 2. x equals 32 or x equals negative 28. Now, you put the 32 up in here and you get 32 minus 2 is 30 and we're probably good to go. You put the negative 28 up in there and you get negative 28 minus 2 is negative 30. I'm not allowed to take the log of a negative. That's extraneous. The answer here is 32. There is more than one way to get that 32, but that's one way. Again, we're doing the same things, okay? We're doing the same things. We're dropping the logs on both sides, and then we are solving. X squared minus 2x equals negative 5x plus 10. Move it over, move it over. X squared plus 3x minus 10 equals 0. Factor, okay? What do you multiply for negative 10? Add for positive 3, negative positive 5, and negative 2. X is negative 5, x is positive 2. Got to check your work. Negative 5 squared is 25 plus 10 is 35. Negative 5 times negative 5, 25 plus 10 is 35. I'm good. Positive 2 squared, that's 4 minus 4 is 0. That's negative 10 plus 10 is 0. Am I allowed to take the log of 0? If you're not allowed to take the log of 0, then this is extraneous. What happens when you take the log of 0? Does it work? It doesn't. There's no way I can take the number 5, raise it to an exponent, and get 0. So that's extraneous. You have to have a positive number in the log spot. So the answer is negative 5. And that's why you got to check your work. These guys right here. Okay, this is different. So if you haven't been paying attention, it's time to pay attention again. Log back in. Log back in. I love it. Okay, the first thing I want to do is I want to get a single log over here, but I notice that this is no longer a single log over here and a single log over here, so I cannot drop the log. So what are we going to do? We're going to write it in exponential form. So I'm going to have x squared plus 5x, and it's going to be equal to base raised to the exponent. It's going to be equal to 6 squared, okay? So if you have only one log and then a number, you have to write it in exponential form. So if you have logs on both sides, you drop the logs. If you have a single log, you get it to one log, and then you write it in exponential form. So two types of problems here you got to pay attention to. So now when I solve this one, that's 36. I subtract it over, and now I can factor, and I get plus 9 and minus 4. And I get x is equal to negative 9, and x is equal to positive 4. Well, is negative 9 allowed to go in there? It's not. And there we go. Same thing here. Wait a sec. Is that the same problem? It's a log base 6 again. But how do you recognize that this is the type? Now I'm going to put these together. Log base 6 of x squared minus 9x equals 2. Right here. I can't just drop logs if I have them on one side. The 6 needs to go over there. X squared minus 9x equals 36. Bring it back. Give me back that fillet of fish. Give me that fish. Okay, and I get x minus 12, x plus 3. And I get positive 12, and I get negative 3. And I realize there's no way I can put a negative 3 in there because I can't take the log of a negative, and the answer is 12. Good stuff. Good stuff. Yeah, this one here, I guess I'd probably bring this up. Yeah, I'd probably just make this into, let's see, if I was doing this problem, and I guess I am, I'd make it log base 7 of x squared, and then I'd put these two together, log base 7 of 81. Again, I got logs everywhere. Single log, single log. Now you can drop the log. 81. I should get plus or minus 9, but obviously you can't have a negative there. So the answer is just regular 9. Good stuff. Okay. Again, you can tell before you start that I have log number. So I'm going to make this into a single log, and I'm going to make it into n, and n plus 4 equals 5. And again, I have a single log. It's got to be, n squared plus 4n equals 2 to the 5th. 2 to the 5th is 32 the last time I checked. And now this is what I can factor, and it factors into n plus 8, n minus 4. So I get n is negative 8 and n is positive 4. And negative 8 ain't going to hold up, and positive 4 is going to hold up. Good stuff. Good stuff. And then we can do, we got a big dog here. I'd get all these together on the left, and then I'd get them together on the right, and then I'd go from there, because I'm going to have, I'd put this up here, and I'd have log base 6 of 16 over 4 squared. Well, 4 squared is going to be 1. And over here, I'd have log base 6 of 1/4 times x plus 1. So this is really going to be the number 1. 1 equals log, whoa. I'm going to have 1, because I can drop these logs. 1 equals 1/4 times x plus 1. I'd multiply both sides by 4, and I'd have x plus 1, and I'd get x is equal to 3. Feel like I should check that one. 3 plus 1 is 4. Yeah, it's going to work out. We're going to be all right. Okay, good stuff. Good stuff. A chemist is testing a soft drink. The pH of the solution is given by that, where H positive is the concentration of hydrogen ion in moles. The pH of the popular, where's notch of a popular soft drink is 2.5. If the concentration of hydrogen ions is increased by a factor of 100, what is the new pH of the solution? So if the concentration of the pH is 2.5, so we're going to have, is this 10 supposed to be a base? I think it's supposed to be a base. I think this is a bad question. I think this is supposed to be base 10, and I don't think that this is written correctly. So I think what it was supposed to be was this. The pH is equal to negative log base 10 of 100. And then I do 10 to some power that is the pH is equal to 100. And then I know that 10 squared is equal to 100. So the pH is 2, and the new pH is 2. So this 10 should have been down here as the base. Poorly written problem. It didn't translate over in what we were doing. And there's your homework, and I hope that you enjoyed the lesson. And if I talked too fast, you should have hit pause, and you should have rewound. And I look forward to seeing your smiling faces again soon. Have a wonderful, wonderful day.